Greetings and welcome to the Introduction to Astronomy. In this week's exploration of the solar system, we will talk about the Hinode spacecraft and its exploration of our solar system, especially focusing on our sun. So let's take a look at this. Hinode was launched in September of 2006 and was put into what is called a sun-synchronous orbit around the Earth. What does that mean? Well, it actually is in a polar orbit, and it adjusts its orbit so that every time it comes around the Earth, it's in the direction of the sun. So it's kind of constantly facing against the sun, giving it a chance to observe the sun, which is its purpose to study. And what it's trying to study is the magnetic field of the sun, to look at that, and it imaged it in optical, extreme ultraviolet, and X-ray. Now, what do we mean by extreme ultraviolet? Well, ultraviolet is a big band of the electromagnetic spectrum. We have the near ultraviolet, which is the lower energy ultraviolet, closer to the visible part of the spectrum. And the extreme ultraviolet is the much shorter wavelengths getting out towards X-rays. So ultraviolet kind of bridges that gap between the violet color of the visible spectrum and the very lowest energy X-rays. Extreme ultraviolet means we're pushing toward the X-ray side of that. Now, what were some of its findings? What was it able to do? Well, we did get detailed maps of the magnetic fields, including up-close looks at many different sunspots, such as the one shown here. And this is actually one of the images from Hinode, taking a look at the sunspot. We can see the very dark, deep portion of the sunspot, which is the coolest portion of it, several thousand degrees cooler than the rest of the surface there. And that happens because, as Hinode helped us to understand, that the magnetic field lines go through the sunspot and they're very concentrated, and that inhibits the energy flow, cooling that section of the sun off a little bit and making it darker relative to the rest. Hinode also helped us to better understand the heating mechanism for the corona. Now, the corona is the outermost atmosphere of the sun, and it has temperatures that reach millions of degrees. The surface of the sun is about 6,000 degrees. So how is this being heated up? And we found things like microflares that were discovered by Hinode that can actually push energy up into the corona and cause those particles to be moving faster, which gives us the increased temperature there. We also found out how the magnetic field dominates solar activity, how important it is for the activity that we see on the sun, which includes things like sunspots and also includes things like solar flares. Now here we can see one of the other images taken by Hinode. This is actually an image of an annular solar eclipse. An annular eclipse occurs when the moon is not quite large enough to completely block out the sun. So from its orbit, it was able to see this. We can see a portion of the sun down below here, and the moon is the dark silhouette blocking out most of the light of the sun here. So it was able to see things like this, as well as a transit of Venus back in 2012. Now, its mission continues, so it's been going for over almost 2 decades now, and it is planned to run at least through the end of the 2020s, so the end of this decade. So let's go ahead and finish up and look at our summary at what we talked about today. And what we looked at was the Hinode spacecraft launched to study primarily the magnetic fields of our sun, giving us detailed maps of the magnetic field structure and helping us to solve the problem of the heating of the sun's corona. So that concludes this week's exploration of the solar system video on the Hinode spacecraft. We'll be back again next week for another exploration of the solar system video. So until then, have a great day, everyone, and I will see you in class.